So in HPC data centers today, what's happening is now that we're building bigger and bigger systems, it's more and more difficult to cool a given amount of compute power. Now, in addition to that, what's also happening is cost of energy is going up, so people are a lot more conscious to try to do the cooling for a lower cost. So this becomes a bigger part of the equation, so it just becomes more and more important to do a better job here. Next to the processor, memory is the highest power dissipation of anything in the system. So memory itself is incredibly important. IBM has a long-term partnership with Samsung in both DRAMs as well as technology. Samsung has partnered with us, and we've made a special memory DIMM just for this product with Samsung that's completely water-cooled. When you cool with water, the components actually run to a lower temperature. When the components run at a lower temperature, they actually in themselves dissipate less power. So this is just an example of Samsung doing something custom and special for us that's giving us a competitive advantage. This is what we call a Power 775 server. This is our latest entry in our Power 7 family of Unix systems. Not only can we fit everything from a raw compute performance point of view in a single rack, a full system that would be 180 times the size of Watson would have 500 times more memory if it's maxed out with our maximum DIMM offering. It's 100% water cooled. It eliminates all the air conditioning in the site facility. So IBM's very committed to high-performance computing, and memory is an important part of that for sure. Basically, when you have this much memory in one spot, the best thing is to make the memory most power efficient as possible. So by doing that, basically the customer will save power overall. When you're talking about this much memory, 4 terabytes per server, it's crucial that the memory itself is lower. So using Samsung memory, we find that the power dissipation is lower than some of the other alternatives. So today we have an 8 gigabyte or a 16 gigabyte DIMM in this package. We're now working on a 32 gigabyte DIMM with Samsung. We're looking in the future at potentially a 64 gigabyte DIMM, 128 gigabyte DIMM, and maybe even larger in future sizes. So as we continue to increase the size of memory, memory is going to become a larger and larger percentage of the power dissipated. So reducing the voltage, trying to stay with greener and greener memory will become even more crucial. So by really customer using these denser technologies, these more modern technologies, they're going to simply save power. And power is money.